Hey there, welcome to the Web Schools and welcome to this two-part series about TypeScript. In this video, you will learn all the basics of TypeScript from the absolute beginning in part 1, and then in part 2, you are going to complete your first TypeScript project. This is going to be a super simple project. Let me give you a sneak peek of what you are going to build after this video. So this is a student's database, and our job here is to get this array and output this table on this HTML page. And even though this seems like something absolutely trivial, there will be some challenges here because this array of students has kind of a weird shape. There will be properties that some students have, some students don't. There will be properties that sometimes come as a string, sometimes as an array of strings, and you'll see how TypeScript can help us enormously in increasing our productivity and writing better code from the beginning. So I hope you are excited because in this video, you will start loving TypeScript. So let's get started, but first, please hit the like button and subscribe to help us out. This channel is just starting, so your help is really important for us. All right, so let's go to part 1, TypeScript Basics. Hi there, in this section we are going to cover the basics of TypeScript. If you don't know anything about TypeScript or know just a little bit and feel you need a refresher, stay with me in this section to learn it from the beginning. So what exactly is TypeScript? TypeScript is a superset of JavaScript, meaning it includes all features of JavaScript plus additional features and capabilities. TypeScript is a statically typed language, which helps catch type-related errors at compile time rather than at runtime like JavaScript does. This leads to a more robust and predictable code. I will show you examples of this in a moment. TypeScript also offers enhanced tooling, which includes powerful features for IDEs and code editors, like code autocompletion, code navigation, and intelligent error checking while you type your code. As TypeScript extends the JavaScript language, you can start using it gradually. If you start a .ts file, which is the extension for TypeScript, you can write plain JavaScript code on it without any problems. In this case, TypeScript will help you improve your code by showing suggestions. Now, one thing to note about TypeScript is that it doesn't run on web browsers. All the TypeScript code we write must be transpiled to JavaScript so we can run on browsers. So TypeScript is a development tool. It's not the end product, at least for now, as there is a tendency that in the future, web browsers will be able to read TypeScript. Now let's see an example of what it means to be statically typed. When we create variables and functions in JavaScript, we don't have to declare any types. JavaScript is very flexible about it. TypeScript, on the other hand, is strict about types, and it gives you ways to be specific about it. In this example, we define an interface for a product. An interface is like a template for an object. We're telling TypeScript that a product can only have these 3 exact properties: a name, a price, and a discount. The discount is optional, hence the question mark. We're also being specific about the types of each property. For product 1, we define a name and a price. These properties are valid and the data types are correct. The discount is optional, so no errors are raised. Product 2 has name, price, and discount, all valid properties with correct data types. So again, no errors. Product 3, on the other hand, has a property named incorrectly, being identified by TypeScript. This could cause bugs and unexpected behaviors in our program. With JavaScript, we would only notice the error when running the application, if we ever noticed at all. TypeScript highlights the error immediately, making us fix it before writing any more lines of code, killing the bug before it even exists. Product 4 doesn't have any wrong properties, but it's missing a required property, the name of the product, therefore being highlighted by TypeScript. We will see many more examples like these in this section. TypeScript also makes our code editor more powerful, letting us navigate to type definitions, giving us hints, and providing intelligent error checking while we type. In this example, we mistyped a function name, something that JavaScript would only tell us when we ran the code in the web browser. But TypeScript not only highlights it while we type, but it also suggests the correct name, making us fix the mistake immediately. So with all we covered in this video, we can now conclude why we should use TypeScript in our projects. Because TypeScript is a robust tool for developers, enhancing productivity and code quality. If you got excited and can't wait to type your first lines of TypeScript code, go to the next video so we can get started. Hey there, now that you know what is TypeScript, let's start a new project so we can start using it. So you can create an empty folder on your computer and open it on Visual Studio Code. So I'm gonna go to File, Open Folder, and here I just created this TS Starter project, which is just an empty folder. You can go ahead and create it on your computer and open it on Visual Studio Code. As you can see, we don't have any files yet, so this is where we're going to start our first TypeScript project. Before we do that, there are some things we need to make sure are installed on our machine. So let's go to Terminal, New Terminal, and the first thing you need is Node.js. If you work with React or Vue.js, you most likely already have Node.js installed. If you want to check it, you can just type node --version. So as you can see, I already have Node.js on my computer. If this is not the case for you, you can just go to nodejs.org and download the recommended version for most users. After downloading it and installing it, you can go back to Visual Studio Code, run node --version again, and then you will see the version of Node you have on your machine. Then if you run npm --version, you will see that you already have npm as well. So these are the first two things that we will need to start working with TypeScript. Now the next thing we need to install is the TypeScript Compiler. Visual Studio Code already has support for TypeScript, so whenever we start a .ts file, Visual Studio Code will automatically bring all the TypeScript features for us, like intelligent error and type checking. But we still need to be able to compile the files because remember that web browsers don't read TS files. For now, they can only read JavaScript files. So everything we type in TypeScript needs to be compiled into JavaScript. And for that, we can check if you have the TypeScript compiler by running tsc --version. So I already have the TypeScript compiler on my machine. If you don't see that, you can just run npm install --global and then TypeScript. I'm not going to run it now because I already have it. You can go ahead and do it. If you have problems with permissions on Windows, first open Visual Studio Code as administrator and then you can run this command. On Mac, you can just start with sudo and then you will be prompted to type in the user password and then you will be able to install it globally. After doing that, you can rerun tsc --version. And if you see the version like I'm seeing right here, you are good to go. Now the next step is to initialize a new Node.js project, and we can do that with npm init. Now here it is going to prompt you to make some decisions, but if you just press enter, you are going to choose all the default options. So here, for example, we don't want to change the package name, so we can just press enter. And let's do the same thing for all the rest of the options. Now it is asking us if this is okay. If we type enter, then it is going to create a package.json file with some basic configuration. Now we can see that the main file for this application is the index.js, but we are not going to be developing in JavaScript. We are going to be developing in TypeScript. So I'm going to create a new file called index.ts. So here we will write TypeScript code. So now we are going to have access to the great TypeScript features, but when we want to run the end product on a web browser, for example, remember that we need to compile this into JavaScript. So this is what the TypeScript compiler is going to do. So as a first example, I'm going to create a new variable. Let's call it message. I'm going to assign a value of hello. Then I'm just going to do a console.log. Then let's show the message in the console. We can save this. Now let me open a new terminal, and in order to compile this into a JavaScript file, we can run the tsc command. But before we do that, we need a configuration file for the compiler. So I'm going to start a new file called tsconfig.json, and this is where we are going to place all the configuration for the compiler. Before we add anything here, let's just run tsc. And as you can see, even without having anything inside here, the compiler already generated the index.js file. So if we go inside here, we will see that TypeScript is going to generate all the code in JavaScript. And now we can just use Node.js to run this file. So we can type node, then index.js, and we can see the message showing in the console. So this is more or less the workflow that we're going to be using for this section. We're going to write TypeScript code, and then we are going to generate the final JavaScript code and run it in the console. Node.js can read TypeScript files directly, but since this is not the case for web browsers, we need to get used to generating our final JavaScript files before we run them. So we are not going to touch this file right here. We are only going to type code inside the TS file. The JavaScript file will be generated automatically. Now we need to improve this folder structure a bit, and we also need to speak about some basic options we can choose for our configuration file. So this is the subject for the next video. Hi there, now that we created our first TypeScript project, before we go ahead and start writing TypeScript code, let's improve the folder structure of the project and let's write some basic configurations for the compiler. So the first thing we need to do here is to separate the source files from the compiled files. And the source files are going to be the TypeScript files. The reason we need to do this is because these JavaScript files, we won't do anything with them. We are not going to edit, we are not going to add any code to these files. These files will be generated from the compiler. The only files we are going to change in our project will be the TypeScript files. So in order to avoid confusions here, let's put them into separate folders. For now, I'm just going to delete the JS file because we can generate it from the compiler later. Let's just leave the main file, which is where we're going to be writing code on, which is going to be the index.ts file. I'm going to open a new folder for the source. So this is where we're going to place all the TypeScript files for our project. So now we know that we should only change the files inside this folder. Now we need to go to the configuration file so we tell the compiler about it. So here, this is a JSON file, so we are going to start a new object here. And by the way, if you search online, you can get a basic template of the configuration file. Since we are only using a few options here, we can type them manually. So here, the first thing we are going to add here is a property called compiler options. Now be careful here to not mistype the name of the property. So this is camel case. We have options with uppercase. And then the value is going to be another object. And here we are going to add the options. So the first option we are going to add here is the root directory. So we can add root dir with a capital D. And now we are going to tell the compiler that we want to check everything that is inside the source folder. And every TypeScript file that we have inside this folder, we want to generate JavaScript files and put them in the output folder. So we are going to add a new option here for the out dir, and we are going to ask TypeScript to place these generated files inside the dist folder. You can name this folder whatever you want, but it is a convention to name it as dist. So now we can save this file, and if we run the compiler again, so let's run tsc in the terminal, you will see that now the compiler created a new folder called dist and generated the final JavaScript file. So everything we have inside the source folder, including an eventual folder structure we have here, is going to be copied exactly to this dist folder, but everything inside here will be in JavaScript, meaning that a web browser would be able to read it. Now, another thing we can set from the config file is the JavaScript version. I'm not sure if you noticed, but if we go to the index.ts file, we used let message to create this block scoped variable. But if we go to the generated file, you will see that the compiler changed this to var. This is because the default JavaScript version used by the compiler is ES3. And this is an old JavaScript version that didn't have let and const yet. In 2023, which is when I'm recording this video, the stable JavaScript version that is supported by all web browsers is ES6, which is exactly the version that introduced let and const. So if you want to make sure you can use that on your final code, you need to tell the compiler about it. So let's go back to the configuration file. We are going to add another option here called target. And here we are going to let the compiler know that we want to use ES6. As you can see, we already have an auto-completion here telling us what are the options available. We have many new JavaScript versions, but remember that by the time I'm recording this video, ES6 is the most stable one. So by choosing it, I can make sure that this is not going to break in any web browser in the market. So I can save this now and run the compiler again. And now if we go to the final JavaScript file, we can see that it is already using the keyword let. So now if we want to run the application in the console to test, we can just type node.dist/index.js. And then we can see the code running in the console. So that was all for now. There are many more custom configurations we can use for the TypeScript compiler, but I'm not going to go deeper into this subject because this is not the purpose of the course. If you want to know more options you can use for the compiler, you can go to the official TypeScript documentation at typescriptlang.org, and then you can go to /tsconfig, and you are going to have information about all the options you can choose for the configuration file. For now, we just need a simple project, so we learn the basics. So let's go to the index.ts, which is our development file, and we are now ready to move on to the next video. Hi there, in this video we're going to start writing TypeScript code. But before we do that, let me show you in the documentation where you can learn more about TypeScript. So we are at typescriptlang.org, which is the official TypeScript website. And if you go to docs, you will find many resources so you can learn more about TypeScript. I'm going to show you the two resources that I think are the best ones for everyone getting started. So first is the summarized version, which is right here under Get Started. And this is the TypeScript for JS programmers. This is super summarized. So in one short page, you have all the basics of TypeScript. So this is probably the best one for everyone in a hurry that wants to learn TypeScript in under an hour. Now, the second one I want to show you, so let's go back here. It's going to be the handbook. This is the best resource if you have time to learn. So this is going to give you much more information, but still this is not too long. So if you focus on learning TypeScript, you can use the handbook to learn it really well in a day or two. So first you have information about the handbook, but the actual TypeScript code is going to start on the basics. So this is going to be our resource in this section to get more information about TypeScript. So we're going to be coming back here a lot. So I show you why I'm doing things. So now we can go back to Visual Studio Code and get started. Remember that we are not going to touch any JavaScript files in the project. These are going to be generated by the compiler. We're only going to be editing files that are inside the source folder, which is going to be the TypeScript files. So let's go to the index.ts. Let's erase what we have inside here, and we are ready to get started. Now, before we dive into types, let's speak about TypeScript's capabilities for intelligent error checking. So for example, if we create a variable, so I'm going to create a new variable and I'm going to call it num1, and I'm going to assign any value to this variable. If we try to do console.log and then we mistype the name of the variable, so for example, I use a name with uppercase like this, or maybe I type it like number1, which seems like a very silly mistake, but in large applications, this could happen easily. So as you can see, this is something that TypeScript already tells us that we are doing something wrong. If we hover over it, it's going to tell us that it cannot find name number1. And this wouldn't happen on a JavaScript file. On a JavaScript file, we would have to run the program before we see the error. So this is what it means to say that TypeScript catch errors during compile time, and sometimes even before that. If we try to compile this, TypeScript is going to raise the error. But as you can see, even before compiling, while we are still typing the code, TypeScript is already catching these errors. And with JavaScript, this error would only be raised at runtime, which means that we would only see this error in the console when we ran this file in the web browser. Now, if we go to the documentation, let me just open the inspector on the side here so we can do some tests. So if we have the same example right here, so I'm going to create a new variable called num1. I'm going to assign a value. And then when I try to do number1, as you can see, there's no errors. Only when we press enter, JavaScript is going to throw the error. So this is something that TypeScript catches, but not only this, TypeScript can also catch non-exception failures. For example, if we have an object, so I'm going to create a new object called student. For this example, I'm just going to assign one property, fName. So the first name of the student is going to be John. If we now try to access student dot and then we make a mistake in the name of the property and try, for example, first name instead, and we press enter, as you can see, JavaScript does not throw any errors. So even though this property doesn't exist, JavaScript can do it without throwing any errors. So this is even worse because even running the program in the web browser, maybe we wouldn't see any errors being raised in the console. And TypeScript is going to handle these non-exception failures as well. So we can do the same example right here. If we want to call student.fName, as you can see, TypeScript catches these mistakes as well. This is telling us that the property fName does not exist. Actually, it's telling us a bit more than that. It's telling us that this property does not exist on type, and then it is showing us a type. Now, it is a bit too early to understand why TypeScript is calling this object a type, but don't worry because this is going to be crystal clear when we speak about objects in more detail. For now, let's use a simpler example so we can see the importance of static type checking. So I'm going to create this variable and I'm not going to assign any value to it. Now, if I create a function, I'm just going to call this function do something. And what this function is going to do is return the value for that student, but it is going to transform this into lowercase. Now we can do this and we can see that we don't have any errors being raised. This is because TypeScript does not know the type of this variable. Now, if we declare an explicit type for this variable, TypeScript can help us identify if we are writing valid code. For example, we can, after the variable name, add a colon, and we can tell TypeScript that this is going to be a string. So after doing that, TypeScript knows that we can apply the toLowerCase function on a string. So all good with this function. But instead, if we told TypeScript that this variable is going to be a number, for example, the ID of that student, now TypeScript is helping us prevent errors by saying that if we're going to have a number on this variable, then this is going to cause an error because we cannot apply the lowercase to a number. So this is why types are so important, because once you know the type of a variable, you know its expected behaviors. And this way, you can identify invalid code early in the process. Again, in JavaScript, we would only know that this is a problem when we ran the code in the web browser. Now, speaking about explicit type declaration, which is what we did here, it is important to mention that TypeScript can also do this automatically. So instead of declaring a type like this, if you just start a variable and you assign a value, TypeScript can infer the type. So now if you hover over student, it is telling you that it just inferred that this is a variable of type number. And again, it is telling you that this is invalid. Now, if we change this to John, we can see that this is not invalid anymore, and TypeScript is inferring this variable as being of type string. And if you check the documentation, you will see that actually this is the preferred way of writing TypeScript. So if you are creating a variable and you are assigning a value immediately like this, you don't have to declare the type because this is unnecessary. You can let TypeScript infer the type for you. So regarding the syntax of TypeScript, we can see that many times a TypeScript code will look just like JavaScript code. From this example here, we can see that there's nothing specific to TypeScript here, which means that TypeScript does not want us to write more code. TypeScript wants to make our lives as a developer easier. So sometimes we will have to write more code to make things safer, but every time we can let TypeScript infer things, we can go ahead and do it. And by the way, what we just did here about explicitly declaring a type is called type annotation. So if we come here and do that again like this, this is called type annotation. And we will see in the next videos when this is actually useful to do. For now, as I just said, we don't have to do this. So in this simple example, our code looks just like JavaScript code, which is a great thing about TypeScript. Now let's go to the next video so we speak in more detail about data types and more TypeScript features. I'll see you then. Hey there, in this video we're going to speak about the primitive data types and how to use them with functions. So here inside the handbook, you can go to the everyday types section. So we are going to start with the primitives because these are the data types that are more commonly used in JavaScript. So these are string, number, and boolean. Here we just have some examples of these data types, and this is just obvious stuff for us. This is the same as how it works in JavaScript. So let's go to Visual Studio Code so we can see how we can use these data types. So we have a variable for a student, and I'm also going to add two new variables, one for the first grade of this student, which is going to be 8, and another one for grade 2, which is going to be 9. And I'm also going to create a variable called isApproved, which I'm not going to assign a value to it right now. This is going to be depending on the average grade for the student. So if it's above 7, for example, then the student is approved. So this one is going to be a true or false value. Now let me just erase this part, and we know that in TypeScript we can do type annotations by adding the data type right after the name of the variable. So we can add a colon and tell TypeScript that this is a string, this here is a number, this is also a number, and this is a boolean data type. Now, we already saw in the last video that when we create a variable and assign a value to it right away, we don't have to do type annotations. So we can erase these ones because these ones will be inferred by TypeScript. So if we hover over, we can see that TypeScript knows that this is a string, this is a number, as well as this one. And this one, since we are not assigning anything, we can let TypeScript know that our intention is to assign a true or false value later. Now, if we are not going to do type annotations here, when exactly is this going to become useful? This is going to be when we start dealing with functions. So functions are the primary way we pass data around in JavaScript. And with functions, doing type annotations is going to be extremely useful. And this is when we're going to start catching a lot of bugs. So let's add an example here. I'm going to create a function called average. This is going to receive num1 and num2, and then we are going to return the average, which is going to be the sum of num1 plus num2 divided by 2. Now we are going to do a console.log, and we are going to run this function called average, and we are going to pass grade 1 and grade 2, so we know what is the final grade of this student. Now, if you want to see the result in the console, let's remember that we need to do two things. First, we need to compile this to JavaScript, because if we go to the dist folder, to this file, you will see that we still have the old code. So we need to run tsc. When you run tsc, this is going to compile this file. And now we can see the final file right here. And notice that the type annotation that we did for the isApproved is not here anymore. This is because JavaScript doesn't have type annotations. So this is used only for development. The final file is not going to show these annotations. So let's go back to the TS file, and to run this, let's run node dist, which is the folder where the final JavaScript file is, and the name is index. We can omit the extension. So if we run this, we can see the result in the console. So far, so good. But now what happens if instead of numbers, we have strings? We can see the TypeScript is really good in catching these things. But now we are not seeing any errors showing. And in fact, if we save this, compile again, and then run it, we can see that we are now having an actual result. We are not having an error. We are having a number, but the number is incorrect. And to me, this is the worst type of error, because at least when you have an error, you have better chances of catching it. But if you have a result, but the result is incorrect, then it is way more difficult to identify that your code has problems. Now, you might think that this is silly, that we would never do something like this. We would never create variables with numbers as strings like this. But what if these grades were coming from somewhere else? For example, let's say we were getting them from an HTML page. So we could do something like document.querySelector. Then, as an example, let's say we had an element with an ID of grade 1 where the grade is. So we would get the inner HTML, and we would do the same thing for grade 2. And this way is something that in a real life situation would be more likely to happen, because we could see the page, see two numbers there, we would be 100% sure that this is correct, but in the end this wouldn't be correct. And the way to find out would be to do type annotations in the arguments of our function. So here we can tell TypeScript that this is only going to work if we have an argument with a type of number. And the same thing for num2. Now when we do this, TypeScript is highlighting an error that we weren't expecting. And if we hover over grade 1, it is telling us that argument of type string is not assignable to parameter of type number. And this is something that maybe it would be a bit hard for us to identify that there's a problem, because we're not seeing the numbers here. We're getting them from somewhere else. But TypeScript knows that when we get the inner HTML of an HTML element, this comes as a string. So TypeScript knows that this is not going to be correct. And by highlighting the error, it avoids this error from happening, because it is calling to our attention that what we are bringing here is a string, not a number. So what we have to do here, we could do something like parse float right here. And as you can see, grade 1 is not a problem anymore. and we could do the same thing for the second value. And as you can see, now TypeScript is letting us continue. So this example was just to show you that sometimes the types of variables are not going to be that obvious. But if we use type annotations correctly, TypeScript is going to protect us from bugs. So now I'm going to go back to what we had before. So instead of getting something from an HTML page, which we are not using in this project, I'm just going to put these strings right here. So let's get 2 and 8, for example. And now we can save this. And if you don't want to be compiling all the time, if you want TypeScript to compile your file automatically, you can run tsc-w. This is going to be watching for changes. So whenever you change your file, TypeScript is going to automatically compile it. So this can be useful to let it running. And then you open another terminal, and in this terminal, you can run your program. So node dist/index. We do this, and now we can see that we have the average correctly. Now, another interesting thing we can do with functions is do the type annotation for the returned value. If you want to do that right after the closing parentheses for the arguments, you can add colon, and then you can let TypeScript know that this function can only return a number. And this can be useful, for example, if we were now to get the isApproved, and if we were not paying attention to the code here, and for some reason we thought that the isApproved would just be the result of the average, we could try to run, for example, average of grade 1 and grade 2. So now TypeScript is highlighting the error right here because it is telling us the number is not assignable to type Boolean. And before running this code in the web browser, we could fix the mistake. So we could do something like the average, and then if it is greater than 7, then the student is approved. If not, the student is not approved. So this is now a valid code. The isApproved can only receive a true or false value. Now, I'm just going to erase this. I just want to highlight that when you do type annotations for the return value of functions, this follows the same rules as when we do it for variables, which means that if TypeScript can infer, you don't have to do it because this is just unnecessary code. For example, if I remove this part of the code, we can see that TypeScript is still highlighting the error. And if we hover over the name of the function, we can see that TypeScript knows the type of the arguments and also knows the type of the return value. Because by looking at the code, TypeScript can infer the data type. So in this case, this is the optimal way of writing this function, because for the return value, we can just let TypeScript infer the type. And now here we can do that comparison again, and we could show the result to the user. So that was all for this video. In the next one, we are going to speak about arrays. I'll see you then. Hey there, in this video, you are going to learn how to work with arrays in TypeScript. And by the way, I'm adding comments in the examples of previous lessons. So by the end of this section, you can download the final version of this project, and it's going to be easier for you to recap everything we covered in this section. So now let's move on to arrays. So let's use a different example here. Instead of having 2 grades, let's say we have multiple grades. So we can create an array of grades. And again, let's use that same example with grades coming as strings like this, so we understand how we should work with this array. Now we could create a new function to calculate the final grade. So let's create that function. Let's call it final grade. This is going to receive the array of grades. And inside here, we are going to do the following. We are going to start a sum variable with a value of 0. And then we are going to do grades dot for each. And for each grade we find, we are going to do sum plus equal to grade. This way, we are going to have the sum of all the grades. And in the end, we can just return sum divided by the length of that array. So we can do grades.length, and this is going to be the average grade for that student. And to see if this is working, we can do a console.log and run final grade over the grades array. As you can see, by doing this, TypeScript is not highlighting any errors. So we can save this, and remember that I'm running the watcher for the compiler. So if you are not doing that, remember to run tsc-w so you compile the TypeScript file automatically on every change. So since this is working automatically for me, I can just come here and run the program. So I'm going to do this, and obviously this is not correct. This can't be the final grade of the student. And what is the problem here? This is because, again, we are not defining types correctly. We have an array of strings, but then when we go inside this function, we are doing something here that it's not going to work well with strings. But if we are not paying attention, we are not going to catch the error. And what we need to do is let TypeScript help us identify these errors. And how can we do that? We can tell TypeScript that we know that this is an array of strings, so we are going to create this function, and we are going to do the type annotation for the argument. And the way we do this is with the data type and then open and close braces. This is how we define an array of strings. If you go to the documentation, you can see that you can do the same thing with numbers. So you can have an array of numbers, an array of strings, an array of booleans. So this is what we are doing right now. And now that we do this, TypeScript is telling us that there is something wrong here. Type string is not assignable to type number. So since we initiated this variable here that can be inferred as a number, now TypeScript knows that we are doing something that it's not correct here. So it would give us the chance to come here and correct this. So now that we know that this is an array of strings and this is not a valid code, we could come here and do something like parse float with each grade. And now TypeScript is not telling us that there is any errors. And in fact, if we run the code again now, we can see that now we have the correct average. So that was all for now. Let's go to the next video so we can speak about objects. Probably the most important topic when working with TypeScript. I'll see you then. Hey there, in this video we are going to speak about objects, the most important data type in JavaScript. So let's create a new function, and we can call this something like print student. And this function is going to receive a student, which is going to be an object, and we are going to do some console.logs right here. So we are going to send to the console the name of the student. So here we are going to do student.name, and we are going to print the final grade as well. So we are going to print final grade. And for that, we are going to run the function we created in the last video. So we can copy the name of this function. Let's remember that this function needs to receive an array of strings. So then we are going to pass as an argument the student.grade. So this is how our function should work. And now we are going to create a new student. This is going to be an object, and this student is coming from an external source, and the properties are going to be slightly different than what we need in this function. So here we are going to have a property called fname instead. So this is the name for this student, and we are going to receive the two properties as grade 1 and grade 2. Now, if we try to run this function, so we are going to execute our function, and we use the new student as an argument, TypeScript is not highlighting any errors. But of course, if we save this, and by the way, I have the watcher running, so the final JavaScript file is compiled automatically when I save. Now I'm just going to run the file, and of course, we are going to have an error because we are trying to run a for each in an undefined type because we don't have anything called grades. So a huge mess, which would require us to go back to the code and spend some time trying to identify all the errors we have here. Now, how can we let TypeScript tell us what is the error? We can define a custom type for this argument. So we know that we can have specific types for arguments by using colon. We could tell TypeScript this is a string or a number or even an array of numbers. We know we can do it like this. But we can also do this for objects. So one way of doing this is passing the object directly right here. And then we can tell TypeScript, no, what is the shape of the object that we are looking for. So we could say that this object must have a name. And the name must be a string. And we also need one property called grades. And it must be an array of strings. Now, when we do this, we have the complete code, and here the error is being highlighted. And we are going to know exactly what is the problem, because we now know that these objects are different. So we would run some transformation in this object to make sure that it has a name and it has grades. And the grades cannot be one string like this. The grades must be an array. So 8 and 7. And now, as you can see, we don't have any errors anymore. And of course, if we run the code again, we can see that now the program is running correctly. So just by explicitly defining what is the shape of the object we need as an argument, we won't be able to proceed if our code is not respecting these rules. So this is one way of defining the shape of the object, but we have other two ways. If we go back to the documentation, as you can see, we have something called type alias. This is inside the handbook under everyday types. So if you scroll down to objects, which starts right here, object types, you scroll down a bit more, and then you have something called type alias. This is useful because then you can keep a cleaner code. So instead of defining the shape of the object here, we could create a type alias. We could call it student, for example, and then we could define this exact shape. And now this is our custom type. So instead of defining it like this, we can just use this custom student type. So as you can see, this is going to work the same way. So running the program, we can see the same result. Now we still have two important topics to cover about objects. So I'm going to break this video into different parts so we learn these things step by step. So I'll see you in the next video so we can continue. Hey there, in this video, we're going to speak about optional properties. So for this example, I'm going to start a new array and I'm going to call it students. So now instead of dealing with one student at a time, let's deal with multiple students. And we could let TypeScript know that the type here is going to be an array of students. For object types, it's not going to be as easy for TypeScript to infer the type, so we can do this when we declare the variable. This is going to help us get those warnings if we do something wrong inside here. So now we are going to add a few students. I'm going to get this one as an example. Now let's add another one. And let's make a change to how this works. So if a student finished all the tests, so let's say we have 4 grades. So this first student finished all the tests and have 4 grades. But the second student, which is Sarah, only has 2 grades, so Sarah does not have the final result yet. But for John, he's going to have one property called isApproved. And let's say this is already calculated somewhere else. We just know that the result is true. Now, of course, TypeScript is raising an error here because we're telling it that this array is an array of students. And if we go check the type, we don't have anything saying about isApproved. So what we could do here is come here to the type alias, and we can add this new property. And we can add this property as Boolean. Now, when we go down there, we can see that John is not a problem anymore, but now Sarah is a problem because Sarah does not have the isApproved property. So what is the best way of fixing this? In this case, since some students will have this property and some won't, and this is something that could happen in a real life situation, there is something we can use in TypeScript, which are optional properties. So after the name of the property, if we add a question mark, then we let TypeScript know that some students will have this property and some won't. So as you can see now, we don't have any errors. If we delete this property, now this is a problem because name is a required property, but the isApproved one is not. Therefore, there's no problem with this second student. Now we could run a loop over this array. So students dot for each, and for every student we find, we are going to do something which is going to be run our print student function. So we are going to run the print student function, and we are going to pass the student as an argument. So all good. These are all valid properties for the student type. This function expects to receive a student, so there is no errors here. Now, since we have this isApproved property, let's modify this function a bit so we can show that information. So we are going to show the isApproved, and this is going to be the isApproved. Now we do this, we save, and we are not seeing any errors in the code. So let's see if everything will run correctly. So let's just do node this /index. So as you can see, the program ran without errors, but now we are seeing something that does not look good. We are seeing this undefined value. This is because we are using a property that is optional. So some students will have it, some won't. As we told TypeScript that this is optional, TypeScript is not raising any errors, but now we need to manage this from our code. So we just need to pay attention to this. Every time we have an optional property, let's not forget to handle that in our code. So in this case, since this is optional, we could test first if we have something inside student isApproved. We save this. Now we run the program again, and we can see that John is showing it and Sarah is not. But is this the best way of solving this? Let's see if John has the isApproved set to false. In this case, John already finished all the tests, so John has all the grades and John was not approved. We save this, we run the program again, and now John is not showing the isApproved. Of course, because this is false, so we are not going inside this if statement. So here, what we could do is the following. We could use the type of operator and test if it is equal to Boolean. Now we save this, we run the program again, and now we are showing it for John, even though it's false, but Sarah doesn't have anything, so we are not showing anything. So this is a better way of handling that problem. So that was all for this video. In the next one, we are going to speak about interfaces. I'll see you then. Hey there, in this video we are going to speak about interfaces. So if we go back to the documentation, right after type aliases, we can find interfaces. Type aliases and interfaces are actually very similar, but they have an important difference that I'm going to show you in this video. So we can see that the way we declare it is similar, with the difference that with type aliases we use the equal sign, but with interfaces we start it just like we would do with an object. So let's go back to Visual Studio Code so we can try to use it here. I'm going to copy all this, and actually I'm going to comment everything so we don't lose this code, and I'm going to add a new comment here for the interface. So here, instead of using type, we are going to use an interface, and here we don't need the equal sign, so this is how we create an interface. As you can see, everything is working the same way. If we save this and we run the code, we can see that everything is working fine. Now, the important difference between interfaces and type aliases is that with interfaces, we are going to be able to change it, to add new properties, and also to extend from other interfaces, which can be super useful. So one example here is the following. I could copy all this, and I'm not going to use the isApproved for now, but I could add it later and just add one more property, which is the isApproved. So as you can see, this is valid. So if I had declared it first and then I want to extend this interface, I can open it again and add a new property. Again, everything here is valid. If we run the code, we can see that we don't have any errors. But of course, it's not super useful to do this because it's actually more organized to have everything declared together. But when you extend from another interface, then things start to get interesting. For example, we could copy all this and we could have the interface for a person, and a person has a name. Now pretend we had many more properties like year of birth, country of origin, and all the properties you can think about for a person. And now for the student, instead of having the name right here, let's go back to the documentation and you will see that you can use the extends keyword. So here I could say that student extends person, which means that the student will have everything the person has plus some exclusive properties. And this, as you can see, works the same. This can be super useful because maybe you have a system that has employees, members, customers, suppliers. So all of them will have some common properties. So you could have an interface for these common properties, and then you could extend that interface and add the properties that are exclusive to each of these types. So I just wanted to show you this, and because you can do that with interfaces, I prefer to use interfaces. If you check on the documentation, it is telling you that they are very similar. You can choose between them freely. But again, since it is a bit easier to extend interfaces, I prefer to use it instead of types. If you want to extend, there's actually a way to do this with the type alias, as you can see here. But what I showed you previously about adding new properties, then this cannot be done with type. So for that reason, I prefer to use interfaces. So that was all for this video. I'll see you in the next one. Hey there, in this video we are going to speak about literal and union types. So starting with literal types, if you create a variable called size and you assign a value of small, we can see that TypeScript defines the type of this variable as string. However, if we explicitly declare the type And instead of adding a string like this, we add the string small. Now TypeScript defines the type of the variable as small. And what does that mean? It means that this is the only value that this variable can have. So for example, if I try to change the value to large, then TypeScript is not going to let us, because small is the only value that this variable can have. So if we don't assign any value at first and we just define the type, when we use the variable again, we can define the value as small. But if we try to define a different value, then TypeScript is going to return an error. Then you might think that this is kind of useless, because why would we define one single value for a variable? Well, a literal type on its own is actually useless, but if you mix this with union types, then it starts becoming useful. For example, if we create a variable for an ID and you tell TypeScript that it can accept two different types. So this variable can accept either a string or, and then you can use the bar and add another type. If you do that, then TypeScript is going to let you add a number, but it's also going to let you add a string. So union types are useful when you can receive data in multiple formats. You just have to be careful, because if you start doing this, you have to handle possible errors yourself. And I'm going to show you what I'm talking about in a moment. But first, let's see how we can then use union and literal types together. I'm going to create a function, and I'm going to call this function button style. So for this function, we are going to accept an argument called size, and we are going to limit the user to specific values. So instead of receiving a string or a number, we are going to add literals here, but we are going to give the user some options. So we are going to accept small and large. These are the only two values that this argument will receive. So right here, we are going to start a new variable called style, and then we are going to define the type of this variable as an object. And this object is going to have two properties: a height that is going to be a string, and a width that is going to be a string. Now inside here, remember that when we have different types for a variable, we need to handle it ourselves. So in this case, we need to do something if the user passes small, and something else if the user passes as large. So here we are going to add an if statement. So we are going to say that if size is small, then the style is going to be height 60 pixels and width 100 pixels. Else, we don't need to add another test here, because there's just one other option, which would be large. So in this case, we would have the style as 80 pixels and the width as 140. So we are creating a style for a button or for any other HTML element. It doesn't matter much here. All that matters is that we just created a function, and we are constraining the possible values to small and large only. So we don't want the user to go crazy and choose arbitrary sizes. We want our page to be consistent. So we are creating this function that will return the sizes, and we are giving users two options: small or large. And now here we are going to return the style. So when we use this function somewhere else, we can do a console.log just to check what it's going to do. And we are going to use the button style function. And if we want to use any value, like, for example, we think that we can use this function as 2px, TypeScript is not going to let us, because 2px is not assignable to parameter of type small or large. So it is telling us that we can only use these two values, avoiding errors in the code. If we pass small, then no problem at all. We can actually go ahead and run the program. So then we can see that passing it as small, we're going to have the sizes. And if we pass large, then we are going to have the sizes for large, and TypeScript is not going to let us use any other value. So we are protecting this function to use only the sizes we intended to have. So this is how we use literal and union types together. Just one last thing I want to show you right here is that if you use union types, TypeScript is going to check if your code would be valid on all the possible types. For example, if we have a function called print ID, we are going to receive an ID, and we are going to tell TypeScript that this can be either a string or a number. If we go inside here and we try to do ID.to uppercase, now TypeScript is not going to let us do that because it is going to tell us that to uppercase does not exist on type number. So whenever you use two different types, you need to do the test yourself, like I mentioned in the beginning of the video. So in this case, if we do a test here and say that if type of ID is string, then we do this. Otherwise, we are not going to do anything if it's a number, and in the end, we are just going to return the ID. As you can see now, TypeScript let us do that. And this is really good because if we have two different data types, TypeScript is going to protect us to write some invalid code that would break in case this was a number. So I just wanted to show you this. I'm going to delete this function for now. So that was all for this video. I'll see you in the next one. Hey there, in this video we are going to speak about null and undefined. So let's create a new function and let's call it print ID. This function is going to receive one argument called ID, and inside here we are going to just send this ID to the console. Now when defining the type of the argument, we can use the null and undefined types. So as you can see, no errors here. We hover over the function, it's telling us that it accepts an argument with the type of null. But of course, this wouldn't be useful because if we know for sure that the ID is null, why are we having the function in the first place? So null and undefined, they will start to become useful when we combine them with other types. For example, we could tell TypeScript that either we are going to have a string or a null value. So in this case, if we still don't have the ID, the function will work anyway. So we can start a new variable right here. Let's call it student ID. And we are not going to assign anything to this variable. And now we are going to try to run this function with this student ID. So as you can see, it's not showing any errors. And by the way, we can use null and undefined interchangeably. So this is why TypeScript accepts the undefined value right here. We could also use undefined and it would be the same thing. So if I save this and run the code, and remember that I have the watcher right here, so the compiler is compiling automatically when I save. Now I'm going to run the program and we can see that the function is running. Now, if we have an ID, for example, ID 22, and we run the program again, the function is working the same way. Now, we just need to be a bit careful when we declare null and undefined. So I'm going to change this example a bit. I'm going to accept a number as well. And here, instead of just sending this value to the console, I'm going to apply the to uppercase function. And now remember that TypeScript checks if the code we are writing is valid for all the types we are declaring. So in this case, since we cannot apply this function to a number, TypeScript is telling us that there is an error here. So how could we fix this? We could have a check in the beginning right here. So we could test if the type of the ID is number. In this case, we are going to do console.log ID only. Otherwise, we are going to do it with the two uppercase. So as you can see, no errors anymore. TypeScript is checking if this code will be valid with strings and numbers. So now we can go ahead. Now doing some tests here, if we define a number and we run the code, as you can see, no problem. If we define a string, so for example, XL78, we save this, we run the program, we can see that we apply the two uppercase to these letters and we are printing the ID with no problem. But if we have an undefined value and we run the program, now we are having an error that TypeScript did not catch for us. This is because by default, TypeScript is not going to check for errors if we declare undefined or null. And this is a big problem. So if we go back to the documentation, you can see that you can turn on the strict null checks on. And if you do that, then TypeScript is going to do that work for null and undefined as well. So we can see here that not having it turned on is a major source of bugs. So they always recommend people turn on strict null checks on. And the place we are going to apply this is going to be on the config file for the compiler. So we can start a new option right here. We are going to add the strict null checks. We are going to set this to true. Save this. And when we go back there, now TypeScript is making the check for the null and undefined as well. So I highly recommend that you use that option on, because then you are going to avoid having errors with null and undefined. In this case, TypeScript is telling us that the ID is possibly undefined, so this is going to generate an error. So then we would have to change this code a bit. We could say that if it is a string, then we can do this. If it's not a string, if it's either undefined or a number, then we can just do this, or we can even test for number. And if we don't have anything, so if it is null or undefined, we can print something like no ID. So this is something that we could have done in the first place, but sometimes it just goes unnoticed. So turning that option on is good because TypeScript is not going to let us have errors when the value is undefined or null. So in this case, we can just run the program again. So we don't have any errors anymore. We just have no ID. If we change this to a number, we can run the program without any problems. If we change this to a string, we can also run it without any problems. So this is how we use null and undefined. And remember to always have this option set to true so you can have an extra layer of security. Unless, of course, you are using TypeScript on an existing code that was previously in JavaScript, and this is raising too many errors. But if you turn this off, remember that null and undefined values can cause errors in your code. So that was all for this video. I'll see you in the next one. Hey there, in this video we're going to speak about the any data type. If we start a variable and we don't assign any value to it right away, when we hover over the variable, we can see the TypeScript defines the type as any. And the problem with the any type is that TypeScript is not going to do type checking anymore. So if we do person equals 2, this is not a problem, and TypeScript is not going to change the type to number. TypeScript keeps considering it as any, which means that if now we define a string, then we are not going to have any errors. And this is not what we want, right? The reason why we are using TypeScript in the first place is because we wanted to do type checking. So we should avoid doing things like this. Whenever you start a variable, if you are not going to assign any value that makes TypeScript infer the type, you should define the type on the declaration. So here we can add the string as the type annotation, and then TypeScript is going to do the type checking. Of course, you can override this. If you set to any yourself, then you can still do the same thing. And this is useful if you just want to exit TypeScript. But of course, you shouldn't use it much, because if you do this, then why are you using TypeScript in the first place? We are using TypeScript because we wanted to be strict about types. So this is something that I do not recommend. And also be careful when you do this, because then you know that TypeScript will automatically define this as any, and you might have problems. Now, with functions, there is a way that we can prevent this from happening. For example, let's say we create a new function. We are going to call it double num. Here we are going to pass a number, and then we are going to do a return num times 2. So we are doubling the number, but we just forgot to define the type of the argument. As you can see, there is a suggestion here, but there are no errors. And now if we do double num and we pass a number, it's fine. If we pass a string, then it's not doing the type checking because it doesn't do it with any. So this is going to cause errors. If we pass a Boolean type, it's not going to do anything, because now that this has been considered as any, it's not going to raise any errors, which is not good at all. So how do we make sure the TypeScript is not going to infer any types as any? If we go back to the documentation, we can see that we can add this flag to the compiler config file. So let's copy this. Let's go back there, and right here, right below the strict no checks, I'm going to add this option, and I'm going to set it to true as well. So when we go back there, now TypeScript is not going to let us continue. It is going to tell us that parameter new implicitly has an any type. So it is not going to let you do that. It is going to force you to define the type, which obviously is the correct thing to do. In this case, this would produce an error, but this error is being catched while we type the code. Of course, you can define any yourself like this, and then TypeScript is not going to raise any errors. Now let's do a quick test here. If we change this to console.log and we pass an undefined value, TypeScript is not raising any errors. So if we save this and run the program, we are having a not a number result, which is never what we want. And this is because we explicitly defined the type as any, so TypeScript is not going to do any checks for us. On the other hand, if we don't do that, because we set that flag to true, TypeScript is not going to let us make this mistake. So we will need to define a number, and then it's not going to let us make this other mistake down here. We will be forced to pass a number. Now, just one thing to pay attention is that even having that flag set to true, this is only going to work for functions. So if you create variables, for example, person, we don't do anything, TypeScript is going to infer the type as any and will let us do anything without type checking. So I just wanted to call your attention to this, because for functions, it is going to protect us, but for variables, it is not. So pay attention whenever you create a variable and don't assign the value immediately. Make sure to do the type annotation. Otherwise, TypeScript is not going to do type checking. So that was all for this video. I'll see you in the next one. Hey there, in this video we're going to speak about HTML elements. This is an important topic because when doing web development, most of the time we are interacting with HTML elements. So let's see how we can do that with TypeScript. I'm going to create a function and I'm going to call it getName. So let's say we want to get the value of an input field. So we are going to pass the input as an argument. And right here, we are going to create a variable called name. And we are going to say that the name is going to be that input field dot value. So we know that when we have an input field on our HTML page, we can select that field and get that value. And then we can just send that name to the console. Now TypeScript is raising an error for the parameter. If we hover over, we can see that the parameter has an implicit type of any. And let's remember that in the configuration, we turned on this rule, so all the implicit any's are raised as an error. If we turn this off, so I'm going to comment this line, and we go back there, now we can see that the error disappeared. But this is not what we want. We want to identify these errors and handle them correctly. So in this case, we need to type this parameter, but this is going to be an HTML element. This is not going to be a string, a number, or a boolean. So how do we define types for HTML elements? If we go to the documentation, right under tutorials, then DOM manipulation, you can see how you can work with different types of HTML elements. So going down here, we can see that when you use, for example, getElementById, this is going to come either as an HTML element or no. So let's start with this type right here. So we are going to define the type of this parameter as an HTML element. And now we are having another error. It's telling us that the value does not exist on this type. This is because HTML element is too generic. It's not all HTML elements that have a property called value. So in this case, we need to tell TypeScript that what we're going to handle here is going to be an input field. And for that, there is a type called HTML input element. And TypeScript knows that this element indeed has a property called value. So now everything is correct with our function. Now let's try to call that function. Remember that we need to pass an HTML element as the parameter. So first let's select that HTML element. So let's do let input is going to be the selection of this element. So document.querySelector. And then we know in our page that we have an input field with an ID of first name. This is just an example. We don't have any HTML files here. But for the example, this is going to work fine. So let's say we selected this element and now we are going to run the getName function and we are going to pass the input as an argument. And now we are having an error. Element union no is not assignable to the parameter of type HTML input element. So again, what is the problem here? The problem is that when we use this method, the query selector, this is going to come either as the generic element or no. This is not even HTML element. This one is even more generic. This one serves for both HTML elements and XML elements. So what we need to do here is type assertion. If we go back to the documentation, let's go back to the handbook, to everyday types. And if we search for assertion, we can see that sometimes we will have information about the type of a value that TypeScript can't know about. And the example that they show here is exactly with an HTML element. So when we do this import, TypeScript does not know how the HTML file looks like. So it can only infer that this is going to be an element or a no. But we can let TypeScript know for sure that we know the page and we know that this is an input field. So we are going to do the type assertion. We are going to use the keyword as, and then we are going to define this as an input element. So once we do this, TypeScript will trust us that this is indeed going to bring an input element. And now, as you can see, everything is valid. We don't have any errors. There is another way of doing the type assertion, which is by using the angle bracket syntax. So instead of using the keyword as, what we could do is have the angle brackets just like HTML elements, like this. And if you use this syntax, you need to place this before the value. So if we do this, we are doing the type assertion exactly the same way we did before. So this syntax is also common to see out there. For this case, I'm just going to go with the as notation. Now moving on with our example, when we do this, we just have to be a bit careful because TypeScript will trust us that this is going to be indeed an input element. But what if we don't find this element? If we don't find this element, this is going to come as no instead. So to protect us from any errors, we need to add the no type to the function. So either this is going to be an input element or a no. So if we don't find the element, this is going to come as no. And the importance of doing this is that TypeScript is helping us identify where things can go wrong. So in this case, it's telling us that if this is no, this line is going to be an error, because we won't find the property value on no. And now the way to fix this, we can add an if statement here, or we can just use the question mark on the input. And this is not specific to TypeScript. This is pure JavaScript. When we do this, we are only going to perform this operation if this value here is not no. If it is no, we are not going to get the value. We are just going to return no. So now we don't have any errors. If we have indeed the input field that we need, then this is going to output the name. If we have a no, this is going to output no, which is good enough for this example. It's just important that we won't have any runtime errors. So this was an introduction of how we deal with HTML elements. I'm not going to go deeper into this subject because in the next video, we're going to start a project so we can apply everything we learned in this TypeScript introduction, and we're going to interact a lot with HTML elements. So let's go to the next video so we can start our project.